All right, so today we're going to take a look at increasing and decreasing functions. For the most part today, we're just going to refocus on finding derivatives and evaluating derivatives at certain points. So first thing I want you guys to do is find the derivative of the function that's given and then evaluate the derivative at each of the indicated points. So I'll show one example with you right now. So for my function, I have f of x equals x squared over x squared plus 4. And for this one, what I'm going to do is use the quotient rule to help me solve the derivative, to find the derivative. So when we differentiate, we're going to have f prime of x is equal to, we have the low function, so x squared plus 4 times the derivative of the high function, which is 2x. Then low d high minus high d low, so we have x squared times the derivative of the low function, which is also 2x because the 4 goes away. And then we want to divide that by the low function squared. So x squared plus 4, and then don't forget the squaring of that part. Now, after this, I mean, what we can do, we can kind of clean this up a little bit if we want here. We could make this thing f prime of x is equal to, we could distribute and make this thing 2x cubed plus 8x minus 2x cubed over x squared plus 4 squared. Now this one does kind of reduce a little bit nicer because this positive 2x cubed and this negative 2x cubed are going to cancel out with one another, and I'll have a simpler function to substitute into. So we have f prime of x is equal to 8x over x squared plus 4 squared. So that'll be a little bit easier for us to find the values of the derivative at those points. So I'm going to just keep the graph up here, and let's take a look at evaluating these derivatives. So first one I want to take a look at is, we'll do the negative one. We'll just go left to right. So what I'm going to do is find the value of the derivative at -1. Now, really what that just means is I take f prime of x, the derivative, and substitute that -1 in there. So it's going to be 8 times -1 all over -1 squared plus 4 squared. All right, when we evaluate this a little bit more, we know that f prime at -1 is equal to -8 over 25. Right, so -8 over 25. What we'll also do is we'll take a look at the derivative of f at 0, right, our second point here. So if I want to find f prime at 0, I'm going to substitute that 0 in. I'm going to have 8 times 0 over 0 squared plus 4 squared, and it doesn't really matter because we have a 0 on the top, but we just want to make sure there's not a 0 on the bottom. So we end up f prime of 0 is equal to 0 over 16, or just plain old 0. All right, so the derivative at 0 is 0. All right, next thing we're going to do is we're going to continue on, find that last derivative, the last value of the derivative, this time at 1. So when we substitute the 1 in, we're going to have 8 times 1 over 1 squared plus 4, and then we're squaring that whole thing. Now this one is also going to be very similar to our f prime at -1. So the f prime at +1 we end up with as 8 over a positive 25. So 8/25. Now there's a couple things I want you guys to think about here. We know that the derivative is the slope, right? Now, if we look at the slope at -1, what we see here is that it is decreasing. It's negative, right? Our slope is negative, and the function, the graph itself, is also decreasing. That's going to be a very important part for us. Another thing that's interesting is at 0, there is no slope. So I'm going to just use let me use maybe our blue marker here. If you look at this point, the tangent line right there would be a 0 slope. That's our turning point in the graph. And then finally, we have the slope at 1, which is positive. And if we look back at the graph, what we see is that the graph takes more of a positive turn again, right? It starts to increase. So what we're going to start to take a look at, and we'll dive deeper into this next week, is if we look at the derivative, we can decide whether or not the function is decreasing, increasing, or maybe even turning, right? Having some turning point involved as well. All right, so try a couple practice problems just like this, and make sure you let me know whether it's increasing or decreasing at those points. Remember, negative slope, decreasing function, zero slope means it's turning. We'll have other words for that a little later on. And then the positive slope is our increasing